6.6, graphs of the other trig functions. This is part 1. We're only going to do secant and cosecant. I figured we'll just do 2 at a time. Okay. On Thursday, we'll do cotangent and tangent to wrap things up. Okay. Now, if you know how to graph sine and cosine, this is pretty easy. Okay. Very simple with it. So I have 2 tables here. We're going to look at cosecant first. Let's go ahead and fill in some of the values for sine of x for those particular angle values. And I know we have exact values like square root of 3 over 2 and so forth, but I'm going to write it as a decimal value so we kind of know what's happening, the behavior of the graph. Makes it a little easier. Okay. So here we go. So we know sine of 0 is 0. Okay. Sine of pi over 6 is 0.5. This would be square root of 2 over 2, which is 0.71. Now we talked about before, as you can see, sine should be increasing, right? Because eventually, when it gets to pi over 2, it reaches its maximum value of 1. So this is good. So 0.87, and then 1. Now going back to unit circle stuff, from 1 to pi, we know sine of pi is going to be 0, so this whole range is going to be decreasing, okay? So let's go ahead and fill those values in. So this is going to be 0.87, 0.71, oops, going outside and 0.5. Okay. Now I stopped there, but if I go from pi to 3 pi over 2, the values will repeat, except the numbers are going to be negative, right, because we're in quadrant 3. But I'm just going to stop there for right now. Okay, now, cosecant. I'll put underneath here. This is 1 over sine. Okay? So, wherever sine is 0, cosecant's undefined. Okay? So that would be here. So it's undefined here because sine of 0 is 0. Okay? And it's also going to be undefined at pi. So those are the 2 spots that cosecant will be undefined. Going back to some algebra stuff, if they're undefined, we would draw asymptotes, right? Remember those dotted lines we would draw forever? Okay. So underneath here, I'm going to put, these are our vertical asymptotes when we graph them. So we're going to have nice vertical lines saying that cosecant cannot go past those lines. Okay. Now, taking all of these values and doing 1 divided by those gives us the following. Okay. So we have 2, 1.4, 1.2, 1, 1.2, 1.4, and 2. Okay. So I can see a couple things happening here. Okay. I can see that, are any of my values going below 1? No, right? So I can tell that cosecant is not going to be small by any means. Okay, I can see that its minimum is going to be a 1. That's for sure. Okay. So looking at just some comparisons here, sine's highest value is 1. Okay, but it's also the lowest value for cosecant. So there's a couple like parallels we could draw from this. Okay, so let's go ahead and do that. So let's now draw this graph now that we know some of these values. Okay, and what I'm going to do first, I'm going to draw sine first, the graph of it, and then using that, we're going to draw cosecant. Okay, so let's go ahead and draw some of these. So let's first graph sine. So we got 1, -1, pi over 2, pi, 3 pi over 2, and 2 pi. I want to use green. I know it's going to be hard to erase. This might be a mistake, but we're going to do it. Okay. So I'm going to draw sine first. There we go. Okay, so there's our sine wave. I'll draw cosecant in green. Now, a couple things. Before I draw it, let's put the vertical asymptotes, right? Okay, so the vertical asymptotes are going to be at 0, so this guy right here, I'm going to put underneath this is VA. Okay, I'm not going to draw a dotted line over it, it's a solid line there. And the other one's going to be at pi, so let me go ahead and draw right here at pi, okay? Now, my period ends at 2 pi, so let me ask you this. Would 2 pi also be undefined for cosecant? What do you think?
Yes, because it's the same as 0.
Exactly. Yeah, we made a full rotation, right? So, we could put another one right here. Okay, so there's my other vertical asymptote as well. So we got 3 of them there. Unfortunately, my table didn't go that way. I wasn't going to list every single value there. I was just going to pi just to see what was happening with it. Okay. So far, so good. Now, how to draw a cosecant? Well, let's use some behavior here. Notice that right here's my vertical asymptote. It starts decreasing, right? This decreases. Then it stops at 1. And then after 1, it starts to increase. Well, sorry, increases. So if you think about it, that's kind of like a parabola. Doesn't a parabola do that? Starts at one end, right? Starts decreasing to its vertex point, and then just increases exponentially on the other side, okay? So that's what's happening here. So I'm going to draw a nice little parabola right there, okay? I try to offset the 1 point so you can see that they're both there. It's the same point, but it's, like I said, it's kind of hard to see, so I try to do it that way. So let's look at a couple things here. The maximum for sine is going to be the minimum for cosecant, okay? And the same thing's going to happen when we talk about the minimum, okay? So right here, it's going to follow the same pattern. Just with negative values. So if I were to continue this table, which like I said, I didn't, it'd be too big, but it's going to be increasing from pi all the way to here, okay? This will be its largest point, but this will be sine's lowest point. Just like over here, this is sine's highest, cosecant's lowest. And then it just starts decreasing infinitely all the way here, not crossing the 2 pi line. So right here in green is my cosecant graph. And there it is. Okay. Now, you don't draw the sine graph technically. You would ignore this part, the red line, and you would just have those two right there. Okay, so this is 1 cycle, or in other words, 1 full period. Okay? So that's 1 full period of cosecant. Now if I want to, could I expand it, like do another period over here to see it? Absolutely, but I'm just drawing one of the periods there. Okay? Let's list some facts. I'm going to list some right here. So notice that the relative maxima and minima for sine corresponds to the relative maxima and minima for cosecant. Okay? So kind of like what I said in the table, the max for sine would be the minimum for cosecant, and then flipped, the minimum for sine would be the maximum for cosecant. So that's one thing I want us just to write down in our notes so we know that. Okay? And we'll put one other note. So our cosecant of x values will never go below 1. Okay? So as you can see here, it doesn't go below 1 because that's its maximum for sine, so that's its minimum there. Okay? I guess well, did that really line up well? Man, that's bad, isn't it? That's not even close. Let's make that better. for secant and cosine. Okay? Now instead of drawing the table out, I'm going to use this as a pattern to figure out what these guys are going to be. Because it's going to follow the same suit here. So let's do y equals cosine of x. Okay. Should we do the same colors? Yeah, let's do red and green again. Okay. So I'll graph cosine first. Yep. Our next step is to put the vertical asymptotes. Now, let's think about that for a moment. Cosecant is 1 over cosine. So wherever cosine's 0, cosecant's undefined. So where would that be? Did I say, sorry, secant. So where would secant be undefined at? Pi over 2 and 3 pi over 2. So we're going to draw our vertical asymptotes right there. Okay. Questions on where we draw, why we drew them there? Because remember, if secant's 1 over cosine, if cosine's 0 at certain spots, which is 0 here and here, 1 over 0, undefined, so we can't hit those. Now looking at the graph over there, we know that the max and min kind of correspond to each other for those two because they're reciprocal functions. Same thing for here. So I'll put this in green. Uh-oh, is this tying on me already? There we go, secant of x. Okay, so here is the largest point for cosine. It's going to be the minimum point for secant. And it's going to go right up to the asymptote. Now, I didn't draw it on the other side because the period length for this is 0 to 2 pi. Okay, so I'm not drawing this part of it here. I'm just ignoring it because, again, I'm just doing it within the interval of the period. Okay, now down here, this is the lowest for cosine. Therefore, it's going to be the highest for secant. So it's going to look like this. Okay, and then the final one, okay, so here's up here. This would be the highest for cosine. It's going to be the lowest for secant. And again, it starts at 2 pi, so I'm not going to draw the full parabola. I'm just going to draw it up to here. Okay, so it approaches the asymptote, but doesn't cross it. And again, I'm not putting this here because it goes beyond 2 pi. So this right here is 1 cycle, or 1 full period for the secant graph. There we go. Now again, you would have to ignore that red line. That doesn't really exist. It's just the green parts. But here's the interesting thing. When we go to graph these, I'm going to draw the red line every time. I'm just going to make it dotted. Okay? Because here's the deal. If I know that the lowest and highest for these two graphs occur at those points, it's so much easier to graph it that way. Okay? And you're going to see that in the next example. So before I move on, any questions on those two graphs, secants and cosecants? Awesome. Okay. I'm going to put just some basic properties of both, and then we're going to jump into, I got 2 examples. And that's it. It's a short lesson, guys. So let me go ahead and put over here properties of cosecant and secant functions. Draw a little table. We're going to look at its domain, range, the period, where does the vertical asymptote happen, and is there any symmetry for those guys? Meaning we need to know if they're odd or even functions. The good news is, I know cosecant is sine, its cofunction. Bless you. Okay, so that's going to help me find some domain stuff. So my domain for cosecant is anywhere that it's a multiple, I'll use k as the integer, multiple of pi. So for all integers k. So any multiple of pi, it's when it's unknown. And you can see that based off the graph. Okay, if you look at the first graph there, any multiple of pi, pi, 2 pi, 3 pi, 4 pi, undefined. Okay, the range. Okay, so it could be less than or equal to -1 or greater than or equal to 1. So it goes beyond the scope of what typical sine does. Period's 2 pi. The vertical asymptote, so that's when you have any multiple of pi, which we already talked about with its domain. So any multiple of pi is where you have your vertical asymptote. And the symmetry, we know that sine is an odd function. Well, cosecant follows the same suit, follows the same pattern. So it has origin symmetry. Okay, and I'll put here because it's an odd function. So, okay. So in other words, if I were to plug in a negative for the function, it's the same thing as the y value being negative. Okay. All right. Let's do the same thing for secant. So if looking at secant's graph, we can see some domain things happening there, right? Can't hit the vertical asymptotes. So for this guy, all x values such that x cannot be, oh, I forgot this is cannot be, guys. No, there we go. Forgot to draw that line. Pi over 2 plus any multiple of pi for all, sorry, k first, then pi. For all integers k. Okay. And let me go on the graph to show you that. So right here, pi over 2, we couldn't have. But if I add pi to it, that's where the next spot can't have in your domain. And if I add pi to it again, it'd be over here, which would be 5 pi over 2, cannot have. Okay? All right. Now, range, it's going to follow suit with the cosecant. So y is less than or equal to -1, or y is greater than or equal to 1. Okay. Period is 2 pi. Vertical asymptote, okay. So that's pi over 2 plus any multiple of pi. So I'm just repeating it for the domain. That's where our vertical asymptotes are. And our symmetry is the y-axis. So that's because it's an even function. So what that means is if I plug a negative x value in, it's the same thing as just the positive value there. Okay? So just some basic characteristics of both graphs that we can pull from what we just did there. Okay. Questions? Yes?
So you said that like sine and cosine are basically the same, but they're just shifted?
Yes,
horizontally?
by 9 degrees.
Are secant and cosecant the same? Like are they the same, just shifted over?
Pretty much. I mean, if you look at it, if I were to shift this to the left, I get that part of the graph, right? If I were to shift this guy over to here, I get that part of the graph where it's at pi. So yeah, good question. Alrighty, let's start graphing these. These are fun to graph too. Here we go. Again, this is one of those situations where I don't want to erase those. I wish I could just like lift them up to the ceiling and just keep them there, but oh well. It is what it is. Okay. Let's go ahead and graph. Y equals 2 secant of 3x. Okay, so that's what we're going to do. I'll color code it again. I think that worked out pretty nicely. So here's what I would do. First, graph the cofunction y equals 2 cosine of 3x. That's what you want to do first, okay? So graph that, and then we can graph the secant part. And the reason why I'm suggesting that is because once we have a graph, we know what the high and low points are, and we can go ahead and start making our parabolas depending on where they're at in the grid, okay? So it's a lot easier to do it that way. So let's just list some facts. So the amplitude for this guy is 2, okay? The period would be 2 pi over my b value, which is 3, so it would be 3. Okay, next, phase shift, there is none. Vertical shift, there is none. Increments, what are we going to count by? So we take our period, okay, divided by 4. And we get pi over 6. And we reduce it. Okay. Next, let's talk about asymptotes, where they're going to be located, okay? We know where they're located currently, but that 3 is going to mess some things up. It's going to change it a little bit. So how do we find the new ones? So this is what we're going to do. So I'll put here VAs. Okay. So anywhere this is 0, I'm going to put it in red. Just this part. That's all that matters. Anywhere that's 0, that's undefined. Okay. So cosine of 3x equals 0. So you're going to figure out what values make it 0. Okay. So currently, okay, and I'm going to go over here. Okay, currently, we know this makes it 0, right? Pi over 2 plus any multiple of that. So let's set the 3x part, okay, equal to pi over 2 plus pi times k. And we're going to solve for x. And when I'm done solving for x, that's going to be my vertical asymptotes that the graph is not going to cross. Okay, so divide everything by 3, I get pi over 6 plus pi over 3, k. So what this is telling me is that if pi over 6, vertical asymptote, and if I add a pi over 3 to it, that's my next vertical asymptote. Add another pi over 3 to it, that's my next vertical asymptote, and so forth. Okay, so whatever this is, if there's nothing there, your vertical asymptotes are just this. That doesn't change. But because the period changed, these are going to move. So setting this equal to this, I can figure out exactly what x values I plug into here, makes cosine 0, which in turn makes this guy 0. Okay? All right. So now we're ready to graph, but any questions on what I've done there? And you'll see when you practice tonight, it's the same routine. Like you'll see this on all my papers. Okay? And I have people ask, do you have to list these if there isn't any? No, you don't have to. It's just, for me, it's just my checklist every single time. Okay. So let's see, the amplitude's 2. Okay, so we'll do that. We'll list the amplitude. Okay, period is 2 pi over 3, and I'm going pi over 6 chunks. So pi over 6 will go here, plus another pi over 6, which will be 2 pi over 6, which reduces to pi over 3. Add another one, and reduce, we get pi over 2, and then we get 2 pi over 3. Now there's no phase shift, so my period will end at 2 pi over 3. If there's a phase shift, obviously I'd have to add the phase shift to it to see where it actually is going to end. Okay. I think now we just got to start graphing cosine, right? So let's graph cosine. I'm going to use red. So we know what cosine typically looks like. It starts with its maximum value, hits 0, minimum value, 0, and then back to its maximum value. Okay? Now I'm going to draw it as a dotted wave, because again, technically that doesn't exist. That whole thing don't exist, but we're going to use it to help us graph the other ones. Okay. Now to graph the secant function. Now I need to put in my vertical asymptotes. And I know from here it's what, pi over 6? Okay, so that's my first one. Okay, so that's in there. And anything, if I add pi over 3 next, that's going to be the next asymptote. So that's going to be over here at pi over 2. But here's the deal. If you don't want to do that, math in your head, anywhere our cosine function hits the x-axis, that's where it's 0, right? So it has to be where the VA is going to be. So over here, same thing. When we're graphing this guy, the cosine function hits here. That's where it's 0. So therefore, secant has to be 0 there. So there's my vertical asymptote. So if you just want to think of it as that way, if you don't want to think of it in terms of like, okay, I got to add this to get the next one, wherever it hits the x-axis, draw your VA. Okay? Now let's go ahead and draw the function. So here's its highest point. So, oh, really? That's junk. Hey, it worked. Do I have another green marker? Hey, I do. Nice. Okay. There we go. Actually, that was nicer, actually. Okay, so this is its lowest point, which is it's going to be its highest point for it. So right there. And then that's its highest point. So we're going to go down to here. And there we go. So what's in green is the actual graph. What's dotted, that red part, isn't part of it, but we're using that to help us graph it. Okay, there it is. So that's the graph of 2 secant of 3x. Questions on the process? Cool. So we did secant, so we got to do what, a cosecant one, and that's it. So we'll do it on this board. Let's graph y equals cosecant x minus pi over 2 plus 1. So we're going to put a phase shift and a vertical shift in this one, which is fine. Again, we're just going to graph the reciprocal function first, which is sine, and then graph the other. So I'll put here, we're going to first graph y equals sine x minus pi over 2 plus 1, okay? We're going to list all the characteristics like I did over there. So let's start with the amplitude first. So it's just 1, because there's nothing in front of there. Okay, the period is 2 pi over b. Well, there's nothing in front of here, so my b is just 1, so it's just 2 pi. Phase shift, it's going to be, remember, it's the opposite, so it'll be pi over 2, and it's going to go to the right, pi over 2, so it's being shifted. Vertical shift, yep, it's a positive 1, which means we're going up. Okay, increments, what are we going to count for x-axis? So we take our period, divide it by 4, so that's pi over 2. Which that one's nice to count by. And the last step is, where's the vertical asymptote going to be located for this guy? Okay, so let's look over here. We're looking at cosecant. So it's any multiple of pi is no good. Well, because I have some stuff going on here, it's going to change it a little bit. So it's going to be sine of x minus pi over 2 equals pi k. Okay? So I'm just going to solve that for x. So I don't need the sine part, I just need to worry about the angle. So let me just take sine out of it. Okay, add pi over 2 to the other side. So the asymptotes are going to be at pi over 2 plus any multiple of pi after that. Okay, so that's where we're going to see those VAs located. But again, we could figure it out nicely just by looking at the x-axis. Wherever it hits, that's where it has to happen, okay? But it's good to have that as a backup just in case something doesn't look right. We can kind of confirm it. Alrighty. go. Okay. That should be okay. Yeah, it should be fine. Okay, we're going to start at pi over 2. Okay. Oh, we need to know where we end, huh? I didn't do that. Okay, so let me put that at the very bottom. So we're starting at pi over 2. My apologies. Where do we end? So we're starting at pi over 2. We'll add the period length to it. Okay. So I can see it's going to end at, let's see, the 2 and 2, which would be 4, so 5 pi over 2. There we go. That's helpful. Okay, now we can start adding these across. So pi over 2, pi, 3 pi over 2, 2 pi, and then 5 pi over 2. Okay. Now, we have some things we have to do. The first one is the vertical shift. So it's going to go up 1. So I'm going to draw this horizontal line, little dotted horizontal line. That's where my x-axis is now. So pretend that I took the x-axis and I shifted it up. Okay, so that's where I'm looking at. Now let's graph sine. Okay, I'll do the same thing. I'll have it in red. So it's going to start here at pi over 2, not at 0, but pi over 2. So pi over 2 is when it's 0, so point goes there. Then sine goes to its highest value. Then it goes back to 0. Then it goes to its lowest value. Then it goes back up to 0. So I'm going to go ahead and draw a nice little dotted sine wave. Okay, just like that. And there's green. Okay, so now we're going to draw the cosecant graph. Let's put our vertical asymptotes in now. Okay, so it's going to be at anywhere where it hits the x-axis, which this is where my x-axis is. So pi over 2, here's the first one. 3 pi over 2, and 5 pi over 2. Okay, so there they are. A lot of dotted lines there. And again, does it confirm with what we did here? Yeah, pi over 2 plus every pi afterwards. Pi over 2, pi over, so we're good. So the algebra is matching what we're doing graphically. And then to finish it, okay, I know that its highest point is the lowest point for cosecant, so we're just going to draw a nice little parabola like that. Okay. And then this is its lowest point for sine, but this is its highest point for cosecant, so it's going to look like this. Okay. And there we go. That's the process. So you're not changing much, which is nice. Like I said, if you know what sine and cosine are, you know how to deal with them. You're just doing the same thing, and then where its highest and lowest points are, you're going to graph it. For secant, you can see how we're not drawing the full parabola because we're trying to stay within the period. But there might be a case where if things get shifted, you might still draw the full parabolas for secant as well. It just depends. Okay? Any questions? You guys are awesome. Okay.